In the previous video, we looked at how we can go about matching nodes, and in this lecture, we're going to expand on that by showing how we can match relationships as well. And so the simplest type of relationship match is if we do a node that is connected to another node. And we use, this is called ASCII art. So you can see that we didn't mention this in the previous lecture, but the round brackets represent nodes, and in this case the dashes between these round brackets represent a relationship of some kind. And so we have node 1 that is connected to node 2, and then what we can do is we can return node 1 and node 2. Okay, so this is saying that there is some relationship which connects node 1 and node 2. We're not specifying the direction here, and we're not getting any information about the relationship itself back. So let's put another limit on this, and we're going to limit it to 1. And so this limits it to one match of this pattern. So the limit is based on the pattern. It's not based on the number of nodes or relationships in the pattern, but the matching of the pattern itself. So we have Keanu Reeves that acted in the matrix. And as I mentioned in the previous lecture, if we go into the rows view, it's going to give back what we returned. So we returned node 1 and node 2, but note that there's no relationship information in here. For us to get that relationship information, we need to do something similar to what we do with nodes and present a variable name. And we do that with square brackets to indicate that there is a relationship. And then within the square brackets, we put in the relationship variable name. So let's go and call that rel. And then like the nodes, we have to return rel as well. So if we go ahead and execute that, you'll notice that this time we get the properties of that relationship returned back. One other thing that I'd like to show here is that we can break this up onto multiple lines if we do a shift enter. So shift enter on return, shift enter on limit, and that is making our query look a lot more readable. And the next thing that I want to show is that we can specify the direction here. And the way that we do that is by using a greater than or a less than sign at either ends of this relationship, one of these dashes going into a node. So this indicates that there is a relationship that goes from node 1 to node 2. And you can think of this as like being a type of arrow that points from node 1 to node 2. We can also do the same thing if we do it the other way. We can have a kind of arrow that points from node 2 to node 1 just by using that less than sign. And personally, I think it's better if we have the arrow going from node 1 to node 2. I think that's a lot more intuitive. So let's have that and see what comes back. Okay, so we have Keanu Reeves has a contact, Christina. And one of the things I'd like to do is be a little bit more specific here, because we're just matching any node that is connected to another node where there's a relationship from node 1 to node 2. But what if we wanted to match all the actors that acted in movies, for instance? Well, what we can do is we can use the type in the relationship, and this is going to look similar to what we do with the labels for nodes. We put a colon after the variable name for the relationship, and then we add in the relationship type. So we have relationship type of acted in. If we go ahead and return that, you'll see that we're going to get, who is this? Keanu Reeves acted in Johnny Mnemonic. Okay, what we can also do is, based on our work that we did in the previous lecture, we know that we can put in, well, let's call this actor, and we can put in a person label to specify that this node must have a person label, and we can also put in movie here and specify that this node has to have a movie label. And then we can return actor, rel, and movie. And if you're unsure about exactly what labels and what types you can use or are available to you in this graph database example, you can go into this database section here and have a look, and it will show you all of the nodes and relationships that are available in the current graph, in the current graph database, I should say. And one last thing before we wrap up this lecture is I want to go and show you how you can specify that this relationship might actually have different types. So maybe we want acted in, but maybe we also want to find the people that directed the movies as well. So what we can do is we can put in a pipe. So this is our pipe. And then we can put in the other relationship type that we want to match. So this is like an OR statement. It will say match actors that acted in or directed a movie. And if we return that, well, we're only putting in one result, but if we put in, say, a limit of 10, then what you'll find is that some of these will be directed relationships. So you can see that, who is this? So Andy Wachowski, he directed The Matrix. There's two different Matrix movies. You can see that he didn't act in either of those. He only has a directed relationship to those movies, whereas all the other people have an acted in relationship to those movies. So we've seen a lot in this lecture. We've seen how you can start by having a really simply defined relationship type between two nodes. So you can start off just with a double dash. You can have arrows in there. You can then specify the relationship type. So we could have directed like that. And of course you can put in a variable name if you want to return that relationship as well. Next up, we're going to be looking at the optional match clause, and we're going to be seeing how we can get a list of all of the movies in our database along with directors that acted in those movies.